Hello, Earth Science students. Thought I'd give you just a quick little primer to hopefully make it a little easier for you to use these spring scales to determine mass. You've got two scales in your kit. The first is this blue one that's for measuring very small masses, things that are 10 grams or less. You can use it, for example, for determining the mass of your paper clips or the mass of your penny. And so the key with this one, it's got a clip on the bottom. What you want to do is find some type of container that you can clip onto here. I'm going to use this little baggie that came with your kit for the oak block. You could use a snack bag, you could use an envelope. If you need to get creative later on in the semester for bigger objects, you can create an envelope out of a piece of paper. But this small little baggie, the oak block, came in, works really well. So you can clip the baggie onto the bottom of your scale. Make sure that it's hanging freely. And then to read these, what you want to do is make sure you're looking in the slit of the scale. Make sure that the object is freely suspended, that it's not touching the table. And then you're going to see a little metal rectangular block. It's got a dark horizontal line in the middle. Look at where that horizontal line is aligned with the scale. The increments on the scale are tenths. If you look, there are 10 little marks between 1 gram and the next. So it looks like I've got approximately 2.2 or 2.25 grams. Make sure you record any mass for the lab to the tenth, since you can measure tenths on these. If this was exactly at 2, for example, it'd be really important for me to record 2.0. So let's imagine that maybe my baggie weighs 2.2 grams, and then I want to weigh a quarter. Well, of course, I know the weight of the baggie empty. Now what I would do is put the object I want to weigh, the penny, the paper clips. In this case, I've got the quarter in here. It looks like I'm getting about exactly 8 grams or 8.0 grams. If the baggie plus the quarter weigh 8.0 grams and my baggie weighed 2.2, that would mean that my quarter weighs approximately 5.8 grams. You can get issues where the object is, of course, more than 10 grams. So if you ever see the scale maxed all the way down, if you see that metal piece going down below the 10, that means that, of course, this object weighs more than 10 grams and it's not going to be accurate. So that's why we gave you the bigger scales that are in the kit. This is another, it's called another spring scale. These are kilogram scales, so they weigh up to 1,000 grams, and they'll be useful for everything else you need in the lab that's heavier than 10 grams. The issue with these ones is make sure that you're using the side that's actually measured in grams. It runs from 0 to 1,000. The back side has newtons, and they're a unit of force, so don't be using that back scale. Use the 0 to 1,000 grams. These are going to be useful for all your heavier objects. The issue here is, what in the world do you do with this hook if you've got to do something like weigh your beaker? And there's a really simple solution to that. Dr. Elby Scott is innovative and helped me figure this out. And that is, make yourself a double loop. I'm hoping you guys can see this against the tabletop. I found cotton string worked the best. It's cheap. If you don't make it the way you like it, it's easy to cut another piece of any length you want. I tried fishing line. That tends to slip off things. A shoelace would probably work pretty well. I think thread would break. So I'd recommend, if you can find cotton string easily enough, that's your best bet. Make 2 loops. Make a small loop at the top. That's going to go on the hook of the scale. And make a bigger loop to go around whatever you're going to weigh. If you know how to do a half hitch knot, that works real nicely. If you don't, just tie a loop. It'll work just fine. And the key is to put the smaller loop on your spring scale. And for the larger loop, you're going to wrap it around whatever you're weighing. And so, for example, for this beaker is kind of an odd thing. You can't poke a hole in it or anything else. But what you can do is just wrap your larger loop around the beaker above the lip. Now you can suspend your beaker, and you can accurately record. You wouldn't hold it, of course, but I'm going to hold it still in the little video. Now you can accurately record the weight of the beaker. The nice thing about this is, now when you need to weigh rocks and things later on in the semester, you can use the same method we were using before of knowing the weight of a container and a container plus an object and subtracting away the weight of the container. So I have a 9-volt battery here. If I wanted to know the weight of the 9-volt battery, I'd measure the mass of the beaker separately. For that matter, I just keep track from this lab, and then I'll know what the mass is all semester long. I would put the battery in the beaker, get the total weight, subtract out the weight of the battery. So I hope that helps you.